Write your own. Here we go. Good old Anne. Suppose a forklift raises a 688 kilogram box 2.4 meters in 45 seconds. How much work is done on the box? Well, work equals, oh, Noah, we've done this dance before. Raises or lifts, which force are we doing work against? In fact, you know what? It's mgh, which is why we were then able to say potential energy is mgh, because energy is the ability to do work. So it's going to be 688 times 9.8 times 2.4. I get 688, that's pretty heavy, times 9.8 times 2.4. 16,200, I'll say, joules of work. One mark. How much power? Well, power is how fast you do the work. It's work divided by how long it takes you. It's the rate at which you do work. It's tiredness. So it's going to be, Justin, I'm going to write down 16,200, but I'm going to use my answer button on my calculator and be more accurate. Divided by 45 seconds. 359 points. You know what? 360. Power. Power is measured in watt? Watts. Okay. So if this was a, do I ask a part C? No. If this motor was 100% efficient, it would have to be a 360 watt motor. It's not 100% efficient. This motor is probably a 500 watt motor or a 700 watt motor, depending on whether it's electric or gas powered. If it's gas powered, those are very inefficient. It's probably a 1,000 watt motor. How much work will I do if I carry an 8.8 kilogram bag 9.3 meters forward? Why 0 joules? Yeah, this is our piggyback. I think it was Justin. I had you piggyback. Yeah. So again, this is the piggyback question. You're not doing any work on the object because the object has neither gained nor lost energy. And again, don't think of tiredness, Cam, as work. You here last class? Did I get? Yeah, you were. Okay, you got the quiz, Cam? Yep. An electric motor develops 65 kilowatts. Hey, folks, that's 65,000 watts of power as it lifts a loaded... blah, 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 blah. How much force? Ooh. Oh. Oscar, how many marks is this question worth? 2. Probably a two-parter. I figured that out so far by this time in the year. Well... power equals work over time. Now, why did I write that? Because I saw 35 seconds, and I saw watts. Oh, but work is really force times distance over time. Okay, I think I know where I'm going here, so let me fix this. I'm going to go like this. Power equals work over time. Power equals force times distance over time. Oscar, what did this question want me to find? How much force? Oh, F. Okay, I can do this. I can do this. Let's get the F by itself. What would I do with the D? What would I do with the T? How will I move it over? Times. Okay. So if I hear you correctly, and I think I do, you're telling me that F is going to be, the power stays where it is. You said I'm going to times it by a T and divide it by a D. Okay, let's double check. Did they give me the power in watts? Did they give me the time somewhere? Did they give me the distance somewhere? And the distance is in the same direction as the force that we're talking about. They didn't try and sneak a fast one on me. It's going to be 65,000 times 35 seconds divided by 17.5. This might work out evenly, or pretty nice at least. Oh. No, not 13. 130,000 newtons? 1.3 times 10 to the 5th newtons, or 130,000 newtons. So if you got that, 2 out of 2. Otherwise, I would go something like this. half mark if I saw that, half mark if I saw that, half mark if I saw that, and then a half mark for the answer. And then I would turn the page. A rifle can shoot a bullet at that speed. Find the kinetic energy. Okay, kinetic energy, that's a half mv squared, which is a half m 0.042, because it's in grams, v 965 squared, a half 0.042 965 squared. 19,600, I guess I'll go with. Is that right? Am I wrong? Mr. Dueck, 0.0042. Devin, thank you. Candy for you. Or Kyle, were you pointing that out as well? Yeah? Okay, candy for both of you. Good gosh. 0.42 times 965 squared. So how about 1,960 joules? That seems much better to me. What work is done on the bullet if it starts from rest? What's this question want me to find, Dev? B. Well, work equals force times distance. Did they give me a force or a distance in this question at all? Don't see one. Work is also the area under a force versus distance graph. Did they give me a force versus distance graph in this question? I don't see one. Then by a process of elimination, it seems to me that work is also the change in potential plus the change in kinetic. That was our third definition of work. And I don't think there's any change in potential. Change in kinetic. What's change in anything? Final minus initial. Now it said from rest, so what's my initial kinetic energy if I start from rest? 0. In fact, you know what? It's the same answer as I just wrote. It turns out the bullet had 1,960 joules of work done on it, and it was all turned into kinetic. Hey, what did the work? Did I ask that? No. Where'd the energy come from? Yeah, gunpowder, stored chemical energy. Okay? Potential energy, but not gravitational potential, chemical potential. If the work is done, oh, okay, so now I have work equals force times distance. How did I know to go with that? Because I just found the work in part B, and Thomas, they're asking about average force in part C. Oh, the equation that has force and work in it is that one there. Did they give me a distance? Please tell me they also get... They did? Okay. Thomas, get the F by itself. Yep. So the work is going to be 1960. I'm going to use my answer button, though. I'll use the 1955 point whatever it was. Divided by 0.75. By the way, the reason I said that, I'm just being fussy. I suspect when you pull the trigger on a gun, I suspect the force is at its maximum right away, because as the bullet moves down, the gas can expand a bit, and so I suspect the push gets a bit smaller, which is why, just as a nerd, I did say average force. I'm guessing. I haven't really looked into ballistics all that much, but makes sense to me. Anyways, divided by 0.75. 2607, I'll go 2610. And force. Newtons. Okay, 1 mark. Number 5, a 50-kilogram shell. Boy, Mr. Dueck, you're on an artillery bit. Well, you know what? It's great for conservation of energy. Is shot from a cannon at Earth's surface to a height of that. What's the potential energy? Oh, potential energy is mgh, which is going to be 50 times 9.8 times 400. 4 times 10 to the second is 400. 50 times 9.8 times 400. 196,000 joules of energy. How much kinetic energy does it have right there? If we shot it straight up, let's assume 0. What's the change in potential? Oh. What's change in anything? So change in potential energy is going to be potential energy final minus potential energy initial. Now it looks like my initial was 196,000. My final is going to be mgh final. It's going to be m50 g final height 200 minus 190, come on, there we go, 196,000. 50 times 9.8 times 200 minus 196,000, and I get negative. Why negative? Because I've lost energy. I've lost potential energy. What did I lose that potential energy to? Mostly kinetic. I'm pretty sure the shell is going faster now. I would have lost some to air resistance, but oh, there's a reason why all artillery shells and rockets all look the same with that tapered point. It's all designed to minimize air resistance. It's also why we make them spiral if we can, so it'd be minimal. 1 mark. Number 6. A bike rider approaches a hill with a speed of 8.5 meters per second. Check. The total mass of the bike and rider is 85 kilograms. Check. Find the kinetic energy of the bike and rider. Okay. KE equals a half mv squared. It equals a half mv squared. Plug and chug. A half mv squared. Bike rider has 3,071, I'll go to 3 sig figs, around 3,070 joules of kinetic energy. The rider coasts up a hill, assuming there is no friction. At what height? Oh, you know what this is? I see a change in height. I see a change in speed. I see a hill, which is kind of a slanty, curvy path. You know what this is a job for? Conservation of energy. And no heat because it says ignore friction. I also know, Max, at the top you've come to a stop, and at the bottom you're at the bottom. Yes, once again, Prince Edward Island gets hosed. It's going to be 3,070. I already know the... Well, you know what? I'm going to do this algebraically. A half mv initial squared equals mgh final. And that way I can cancel out the m's. Yay! And I can say to myself, the final height is going to be equal to v initial squared divided by 2g. Divide the g over and the 1/2 in front. That's the same as a 2 in the bottom. It's going to be, what was my initial speed? 8.5 squared divided by 2 times 9.8. 3.7? People nodding? Yep. 3.7 meters. And then it'll start coasting back down. Suppose an object is traveling at 10 meters per second. What happens to its kinetic energy if we double its velocity? What's on the v squared? So if we double its velocity, it's not going to be twice as big. What's it going to be? What if we tripled its velocity? 9 times more energy. Folks, This is the difference between a car accident at 80 kilometers an hour and a car accident at 20 kilometers per hour. The difference in speed is 4 times, but the difference in energy is 16 times more damage. So slow down. So if you want the reason, because of the squared. Suppose a toy car is at the top of a ramp, neglecting friction. How much kinetic energy? Oh, 3 marker. Okay, first they want how much kinetic energy. I'm going to call that part A. Kinetic energy. Oh, they didn't give me a V. Oh, is there a change in height? Is there a change in speed? Then this is a job for conservation of energy. And at the bottom of the ramp, Noah, I can safely say that. And at the top of the ramp, I can say that. You know what the final kinetic energy is? Prince Edward Island. PEI. mgh equals ke final. The final kinetic energy is going to be the mass, 3.5. That's a really heavy toy car. 9.8, 2.3. And I get 78.9. What? I guess joules of energy. B. 1 mark for that. What will its speed be at the bottom of the ramp? You know what? I would also probably give you 1 mark for just writing the law of conservation of energy, because this last line is going to be Ke equals a half mv squared, which means 78.9 equals a half mv squared. Kyle, when you're done yawning, I want to get the v by itself, don't I? How would I get the v by itself? Kyle, what am I going to do with the m? How will I move it over? And what will I do with the 1? Don't care. What will I do with the 2? The 2 is on the bottom, so dividing by 2, how will I move it over? Times by 2. If I hear you correctly, and I think I do, you're telling me this. V squared is going to be 2 times 78.9 divided by the mass. How do I get rid of a squared? So it's going to be, I'm running out of room, 2 times that answer divided by, the mass was 3.5. That's fast. Oh, what have I forgotten to do? Square root. I was going, wow, that's faster than a car on a freeway. That's really fast. It's about 90 miles an hour. 6.7 meters per second. That gets you 1 mark. If you'd be so kind as to give yourself a lovely score out of whatever the heck this is out of. 16, apparently.